Welcome to qnawire.
In this problem, we have to find the centripetal acceleration on a blade of an engine that is rotating with a given frequency and radius. So we know that the equation for angular acceleration is v squared over r. Now we're not given v in this problem, but we do know a relationship between v and frequency. Frequency is equal to v over 2 pi r, and if you're confused by that, that comes from the fact that frequency is equal to omega over 2 pi. Now we can rearrange that to solve for v, which is then equal to f times 2 pi r. That gets plugged back in to our first equation, and now we have everything in terms of given quantities. So v is equal to 2 squared pi squared r times f squared, which is equal to 4 pi squared times 0.02 times 617 squared. And that is equal to 3 times 10 to the 5th meters per second, which is the answer to part A of our problem. Now for part B, we have to find that acceleration in terms of the gravitational acceleration, g. Now, this is really easy to do. All that we need to know is what the value of g is, which is 9.8 meters per second squared. Oh, whoops, and I just remembered that for here, this should be meters per second squared. This is an acceleration. Always remember to keep track of your units. So now we do in fact have the same units here, which means that we'll get a unitless number, which is correct for a fraction. So when we do out this math, we get that this value is equal to about 3.1 times 10 to the 4 times g. And that is going to be the relation between these two, which is the answer to part B, and we've solved the problem.